Welcome, students. So we are going to discuss now power series. So recall, what are polynomials? So polynomials are a form C0 plus C1x plus C2x squared dot Cnx to the power n. All right, so they stop at some point where n is a non-negative integer and C0, C1, C2, Cn are constants, which are also called the coefficients of the polynomial. For example, you have x squared plus x plus 1, or say 0.1 x to the power 10 plus x square plus x minus 5. These are examples of polynomials. Okay. Now, what you do is, so power series are generalization of polynomials in one sense. So what you do here is that you stopped at some Cn, but instead of that, you keep on adding them up. So C0 plus C1x plus C2x squared plus C2x cubed dot. Keep on going forever, then this object is defined to be as power series. Now here x is a variable and you call C0, C1, C are constants, and these are called the coefficients of your power series. Now instead of x to the power n, if you have x minus a to the power n, then this is how the power series looks like, right? So this series is called power series centered at a. Yeah. Whereas this series, power series, is centered at what? X to the n can be written as x minus 0 to the power n. This power series is centered at what? 0. So this series is centered at 0, this series is centered at 1. Now, let's consider the most basic power series we can have. So in this series, if we take Cn to be all 1, we get 1 plus x squared plus x cube dot. You keep on going forever. This is same as summation n equals to 0 to infinity x to the power n. And you can connect this with a geometric series, right? So this is geometric series. Why is it a geometric series? Because you start with 1 and then you multiply by x, then you multiply by x to get, so times x, again multiply by x, right? So times x, you basically get the next term. So this is a geometric series. So geometric series with a equals to 1 and r equals to x. So what happens? This converges if absolute value of x is less than 1. That is minus 1 less than x less than 1. Otherwise, it is divergent. Right? So we want to basically ask the question, if we are given a power series, to see whether it converges or not, right? Now, this is all the part of the bigger plan. The bigger plan is to be able to write down a function as a power series. Yeah. So this, you can write this as, so in this case, you can write it as 1 upon 1 minus x. But you can only write it down this way only when absolute value of x is less than 1. Otherwise, this doesn't make sense, right? For example, if you take x equals to 2, you get what? 1 plus 2 square dot, which is going to be summation n equals to or n on one side, and on the other side we get 1 upon 1 minus 2, which is minus 1. Yeah, so this seems to be, so these functions don't work out to be equal. So this equality only holds when absolute value of x is less than 1, or if x is in this interval. Otherwise, this doesn't hold. So it makes sense to talk about where these two things hold. All right. So let's ask the following question. We have, for what values of x belonging to R does this series converges? So this is almost like an alternating series, but instead of constant, you have a variable x in it. Yeah. So for some choices of x, it will converge, and for some choices of x, it will diverge, right? So we'll have some choices of x. In particular, if you take x equals to 2, if you take x equals to 2, what will happen? This series will become, all the terms will be 0, right? So this series is equivalent to 0, right? Because x minus, so you'll get, if x equals to 2, we get summation n equals to 1 to infinity minus 1 to the power n, x minus 2 to the power, so 2 to the 2 minus 2 divided by n times 4 to the n, which is 0. So convergent. And it is possible that for some value of x, this may diverge. Yeah, it depends on the series. Yeah, depending on the series, for some values of x, it may diverge, right? So we want to decide on this. How do you decide this? Yeah, so we'll use ratio test. Okay, so so often we use ratio test, and sometimes root test. So again, we'll use ratio test here. So ratio test. So your L in this case is limit as n goes to infinity an plus 1 upon an. In this case, your an will have the whole term, all this term, but with x in it. So an plus 1 is going to be limit as n goes to infinity. An plus 1 is going to be minus 1 to the power n plus 1 times x minus 2 to the power n plus 1 divided by n plus 1 times 4 to the power n plus 1. This is your an. And what is your an plus 1? And what is your an? You're dividing by an, so that is same as multiplying by the reciprocal of this guy. So now you can cancel some terms. So when you cancel the terms off, you will get that this term goes away with this term, this n will go away with 4 to the n, and this term will go away with this part here. So what is left out? So this is going to be limit as n goes to infinity x minus 2 divided by 4 times n into n plus 1, an absolute value of that. And that is limit as n goes to infinity, right? So we get this part here. So we get limit as n goes to infinity of this guy, which is absolute value of x minus 2 divided by 4. And that is equal to your L. So this, if this is less than 1, so we have the following. If by ratio test, if L, which is this guy here, if, so when I took the limit, I should have gotten rid of this because there's no n here. The ratio, this by ratio test, it converges when absolute value of x minus 2 divided by 4 is less than 1, that is x minus 2 is less than 4. Yeah. Now it diverges, so, and diverges if x is greater than x minus 2 or 4 is greater than 1, right? So we have this converges when we have this. And now how do I simplify this part? I can simplify it as follows. Minus 4 less than x minus 2 less than 4, right? Why is that? Because we have the following. Since absolute value of x is less than a implies minus a less than x less than a, we get from here, we get this, or if you simplify it further, you get this implies minus, add 2 on both sides, so you get minus 2 less than x less than 6. So therefore, what do we get? We get this part here, minus 2 less than x less than 6. However, the ratio test is inconclusive at what? At x minus 2 by 4 equal to 1, that is when x equals to what? When x equals to minus 2 and x equals to 6. At these points, the ratio test is inconclusive. So we'll test them separately. So let's test these points separately. So how do we test it? So let's take x equals to minus 2. Put it back, plug it in the equation, plug it in the power series. So we get what? Summation n equals to 1 to infinity minus 1 to the power n, and minus 2 will become minus 4. So we have minus 1 to the power n minus 4 to the power n divided by n times 4 to the n, which is going to be summation n equals to 1 to infinity. So this will become 4 to the n, and 4 to the n will cancel with this 4 to the n. So you have 1 upon n, which diverges. Yeah, P series with P equals to 1. So it diverges. So x equals to, now we have to check for x equals to 6. The series will become what? Summation n equals to 1 to infinity minus 1 to the power n. 6 minus 2. So 6 minus 2 is what? 4, right? So we'll get 4 to the power n divided by n times 4 to the n. This will become summation n equals to 1 to infinity minus 1 to the power n over n. And this converges. And the reason is what? Alternating series test. Therefore, we can see that, therefore, if x belongs to 2 to 6, so 2 is excluded, right? Because at 2, it did not converge, and 6 is included. So therefore, x belongs to 6 gives convergence. Right? Because here already you have that if this is less than 1, we have the convergence, right? And if this is greater than 1, let me write that part too, although it's clear. If this is greater than 1, then series diverges. Right? So if x minus 2 over 4, right? So here, so first of all, what is the center of the series? The center of this series is 2, right? So in this case, we will choose to call this 4 here sorry, this 4 will be called, we'll see that soon, this will be called radius of convergence. And this interval will be called interval of convergence. Okay, so we'll see that definitions very soon. So here we have, so let's look at the following example now. So consider the following function. It's called Bessel function of order 1. What is the domain of this function, J1? So this, in this, when you ask what is the domain of this function, it's basically essentially asking for what values of x, for what values of x does this series converges, right? So for what values of x does J1 converges, right? Otherwise, you can't write it J1 of x equals to infinity, right? If it converges, doesn't converge, right? So this is a very interesting function because you can see that this is also used in electromagnetism, particularly in electromagnetic waves. This is also used in heat conduction, also used in planetary motion approximation of functions. This is a very interesting function, all right? So let's see Bessel's function, where does it converge, all right? So again, we'll use ratio test. So use ratio test. So use ratio test. So again, we have L equals to limit as n goes to infinity, an plus 1 upon an. Note that you can also use root test, but in this case, root test may be slightly more involving. It will not be as straightforward as ratio test, right? So these are the two tests we usually use, but we are going to use ratio test here. So we have minus 1 to the power n plus 1 times x to the power. Now, instead of n, it is n plus 1. So I'll write n plus 1 plus 1. We'll have n plus 1 plus 1 times 2 to the power 2 n plus 1 plus 1. This is my an plus 1. Wherever there is n, I'm putting n plus 1. And now dividing by an is same as by the reciprocal. So we have 2n plus 1, n plus 1 factorial, 2 to the power 2n plus 1. So now we can get rid of the minus sign right away. So we have, this is same as limit as n goes to infinity. Now minus will, because of the absolute value sign, you can get rid of that. You have x to the power 2n plus 3. In the bottom, I have, so we have n factorial, right? So we should have had n plus 1 factorial there. So n factorial times n plus 1 factorial. So here also we'll have n plus 1 factorial. So let me just write it down. Limit as n goes to infinity, n plus 1 factorial. Here we'll have this. Okay. So this is actually what it is. So we have written down all the terms now, multiplied by 2 to the n, this. Okay, now every terms are there, all the terms are there. So we get this part on the top. In the bottom, we have n plus 1 factorial, and we have n plus 1 factorial here. So this guy will cancel out with this guy. Now, what about 2n plus 3? So this is going to be 2n plus 3. So let me just write it down anyway. We can cancel it in the next step. So to the power 2n plus 3. Now what survives? We have in the denominator, we have x to the power 2n plus 1. And on top, we have 2n, 2 to the power 2n plus 1. And then this extra part here, which was what? Which is going to be 2n plus 3 factorial. So that is n plus 1 plus 1 factorial. That's going to be n plus 2 factorial. And on top, we have n factorial. Okay, so this is what the limit is, and you have absolute value of this guy. So let's cancel these terms now. So we'll cancel this term with this term. We'll get, so if we cancel those terms, what is left out is limit as n goes to infinity. We'll be left out with 2. So we'll be left out with 2 square in the bottom. N factorial and n plus 2 factorial, when they cancel out, we'll have n plus 2 times n plus 1 times n factorial, which will cancel with the n factorial on the top. So let's just erase that. And on top, we'll be left with x squared. And since we are taking the absolute value of x squared, well, so we get this, and this limit is going to be 0. And notice that this is always less than 1 for all x belonging to R. That means, in other words, all x give convergence, right? So this means what? J1 of x is convergent or converges for all values of x, and its domain hence is what? Domain is R. So let's look at another example. So before we go further, I will basically have another example from, I'll borrow this example and try to do the same thing with this example and see what do we get. So A, we have summation n equals to 1 to infinity n to the power n x to the power n. So in this case, again, we'll use, so we can now use root test here, right? Root test will be easier. You can also use ratio test, by the way, root test. So look at nth root of absolute value of an, which is going to be n to the power n times x to the power n 1 over n, limit as n goes to infinity. This is going to be limit as n goes to infinity n absolute value of x. And this is infinity unless what? Unless x is what? Unless x is 0. Therefore, the interval of convergence is, what is the interval? What is the values of x it converges to? It only converges. It converges for x equals to 0 only, right? So now we have seen few examples here, and the underlying idea is the following. In one of the examples, let's say start with this one, it converges when absolute value of x is less than 1. Here the center is what? X minus 0 is less than 1. In this case, here the center is 2 and we have x minus 2 is less than 4. So it only converges when it is less than 4. Here it converges for all x in R. What is the center in this case? Center is 0. And again, no matter what R is, it is always convergent. And here it only converges at center. All right. So this generalizes the nature of power series about the convergence aspect of it. So what is the nature? So given a power series n equals to 0 to infinity, Cn x minus a to the power n, there are only three possibilities. One possibility that it only converges when x equals to a. Like this example here. It only converged at x equals to 0, which is the center. So if you have the center as a, there are some series which will only converge at center. Second one is that it converges for all real numbers. As we saw for this example here, for the Bessel's function, it converges for all real numbers. Third situation is there's a positive r such that series converges if absolute value of r is less than absolute value of x minus a is less than r, and diverges if absolute value of x minus a is greater than r. And for x minus a equals to r, you have to check separately. So this r here is called radius of convergence. And the interval of convergence is the interval that consists of all x values for which the power series converges. So for example, if you look at this guy, summation n equals to 1 to infinity minus 1 to the power n, x minus 2 to the power n, divided by n times 4 to the n. Your radius of convergence was what? Radius of convergence is when x minus absolute value of x minus 2 less than what gives me the convergence. If you go here, you will see that was equal to what? That was equal to 4, right? So here the radius of convergence was 4. Radius of convergence, which is r, is 4. And the interval of convergence look at interval of convergence. Let's see what is the interval of convergence in this case. Interval of convergence was 2 to 6. So interval of convergence was 2 to 6. 2 included, 6 excluded. Secondly, for this guy, for this problem, the radius of convergence is what? 0, right? And interval of convergence for this example is just a singleton element, 0. So it only converges at center. Note that every power series will converge at center, right? So now, similarly, for J1 of x, radius of convergence was what? So the center was 0 and it converged for all real numbers. So how much is this r? How much r can we go? We can take r to be infinity. And interval of convergence, IOC, I'm going to use the short form for now, is minus infinity to infinity. So now we have already done A. Let's look at problem B now. So again for B, so the steps are pretty straightforward. So first you'll use ratio or root test to find out the radius of convergence. Okay. So step 1, use ratio or root test to find radius of convergence. In this case, we are doing problem B now. So let's apply this. So I'm going to use ratio test. All right. So let's see, what will ratio test give me? So limit as n goes to infinity of an plus 1 upon an This is going to be limit as n goes to infinity, x to the power n plus 1 upon n plus 1 times 3 to the power n plus 1 divided by dividing by xn, dividing by an is multiplying by the reciprocal of it, n times 3 to the power n. And then after the simplification, we can see this is going to be limit as n goes to infinity, x to the power n plus 1 and n cancel to give you x, 3 to the power n plus 1 and 3 to the n, that simplifies to 3, and n upon n plus 1, if you look at this limit, is going to be absolute value of x by 3. So it converges. So if less than 1, converges. That means what? This gives us absolute value of x is less than 3, then there's a convergence. So it's like x minus the center, right? Center is 0 for this guy, right? So we have, therefore, radius of convergence is 3. So that is R. Now step 2, find the interval of convergence. So this gives me, so absolute value of x less than 3 automatically gives me the following. Now we have to check at endpoints. So first endpoint is what? X equals to minus 3. Then the series becomes summation n equals to 1 to infinity. What is my series? So instead of x, I will put minus 3. So minus 3 to the power n times n times 3 to the power n. This is going to be summation n equals to 1 to infinity. Minus 3 can be seen as minus 1 times 3. So it's going to be minus 1 to the power n, 3 to the power n divided by n times 3 to the power n. And then when you cancel 3 to the power n off from numerator and denominator, you get this guy, which is convergent using alternating series test. So using alternating series. The same way, when x equals to, now we need to check for x equals to 3, we have series becomes, so check for x equals to 3. So series becomes summation 1 to this. What do we have? We have 3 to the power n divided by n times 3 to the n, which is going to be summation n equals to 1 to infinity of 1 by n, which diverges. Again, P series with P equals to 1, or you can say it's a harmonic series, which is divergent. So therefore, interval of convergence is minus 3 to 3, minus 3 included, 3 excluded. Okay, so in some sense, radius of convergence already decides, yeah, how the interval of convergence is going to be, except you have to check for endpoints separately. Yeah. So now, why is it called radius of convergence? Because think about it in the following way: you have here 0 is just, so you are the center of the power series in this case is what is basically 0. So from 0, you can think about drawing a circle of radius 3. Hmm? But note that circle of radius 3 in the real number line will look like an interval. Yeah, right. So you're going 3 here, 3 here, and here the guarantee, the convergence is guaranteed, and that at this point, check separately. Yeah. So, and inside, the convergence is guaranteed, right? At endpoint, you check separately, and you saw that what 3 minus 3 was included, and this guy was excluded. Right? So let's look at the next problem. So we have C, which is summation n equals to 1 to infinity minus 1 to the power minus 2 to the power n x to the power n divided by 2n factorial. Again, we'll use what? First step one, we'll find radius of convergence. So find radius of convergence. I'm going to use a acronym for that. So for that, we have to compute limit as n goes to infinity an plus 1 divided by an, which is limit as n goes to infinity minus 2 to the power n plus 1 times x to the power n plus 1 divided by 2 times 2n plus 1 whole factorial times, here we get what? 2n factorial minus 2 to the power n x to the power n. Now this can be simplified further as, so 2 and 2 to the n, when you cancel these guys off, you will get minus 2, and we are taking absolute value of that, so it's going to be 2. So limit as n goes to infinity, so 2 absolute value of x divided by, here you have 2n factorial, you have 2n plus 2. So 2n plus 2 is same as 2n plus 2 factorial is same as 2n plus 1 times 2n, sorry, 2n plus 2 times 2n plus 1 times 2n factorial. So you can cancel those things off. You'll be left with what? In the denominator, you'll be left with 2n plus 2 times 2n plus 1. Now, and everything else is cleared off. Now you have to basically as check what happens as n goes to infinity, right? So as n goes to infinity, this becomes what? This becomes 0, and that is always less than 1. So therefore, in this case, radius of convergence is what? Infinity. And interval of convergence, let me use a short for that as well. I'll use the acronym IOC, which is interval of convergence minus infinity to infinity. Now, what does it mean? It means that you are at center 0, and how far can you go from the center so that the convergence still holds for all x, right? So you can go as far as, you can't use, say, the word infinity, you can't go, but you can keep on going forever, right? So therefore, radius of convergence is infinity, interval of convergence is minus infinity to infinity.